Hello and welcome everybody at our TruEra Challenge Build LLM Applications with Google Cloud Vertex AI Hackathon. We're super excited to have you all today, and it's a pretty huge hackathon that we're hosting today with our amazing partners that are TruEra and Google Cloud Vertex AI together. And this hackathon is solely focused on enhancing and improving the output of LLM-based applications. And I'm excited to kick off this event and explain you how everything will be happening during this hackathon to you. I'm Alessia, and I'm an event manager at LabLab.ai, and I will be your guide through this hackathon today. And also, I'm happy to monitor Twitch chat for your questions. So if you have anything that you want to solve right now, feel free to ask on Twitch, and I will be happy to cover this during the stream. When it comes to the event schedule and schedule for Holy Hackathon that we'll have, let me just briefly go through this and explain you what will happen during this hackathon. So we will be starting with kickoff stream right now. From this moment, the hackathon is officially started. Then we are moving to the opening words from TruEra, and we have Anupam who will be introducing TruEra for you with short opening words. Then we go to hackathon guide and platform walkthrough, where I will show you live how to deal with our platform and where you should find the most crucial functions for your team formation and for finding access to Google credits for this hackathon. So that will be covered. And today we'll have two big workshop sessions that will be practical for everybody that wants to start building right straight away. So we will have Google Cloud Vertex AI and TruEra workshop focused on enhancing and evaluation LLM output with Palm 2 as an example. And then there will be Zilis and TruEra workshop where you will learn how to use the vector databases together with TrueLens by TruEra. And today we'll have in the end of the day, general Q&A session on Discord together with our mentors. This session you can join and solve any questions you might have regarding team formation specifically, since we're kicking off the team formation time. Over the week, we'll have one more session with Llama Index and TruEra focused on RAG specifically for this hackathon and RAG working with RAG output utilizing TrueLens. And then over the week, we'll have two more general Q&A sessions on Discord that will help you to solve your issues or get answers on any questions you may have over the hackathon. And the deadline will be on Friday. Until this time, you have to submit your ready solution for evaluation, and we'll be happy to review your submissions right after the deadline. And now I'm happy to introduce Simon Olson that is joining from LabLab.ai side, and he's the co-founder at New Native and LabLab. Simon, always happy to have you on the streams. Please tell us about LabLab, about New Native, and also maybe you have some interesting updates for us to know.
I wish I was a part of the TrueLens team. They're really great to work with. So I appreciate that we finally got this event together, because this is something that I've been waiting for quite some time. I mean, a couple of words about what we are doing here at LabLab. I mean, we've for a long time now been a part of this ecosystem, and we're really trying to help more and more people get into the space of building with AI technologies, and especially with great partners, just such as TrueLens. So we're happy to be able to run this event, and it's great to see that there's plenty of people who have signed up for this. Yeah, I'm very excited. Also excited to have the RAG component here a little bit later. So that's also something that'll be pretty cool, I think. But yeah, we're happy to have you as always. We're looking forward to this, and it's great to see so many people. I look a little tired today. I've had COVID the entire week, so I had a rough week. Let's put it that way. But now we're back to building again.
Thank you so much, Simon. Do you want to say a few words about New Native?
Yeah, sure. So just on New Native, what we are striving to do, and also amplifying what we do with LabLab, is to make sure that people have access to technology. And we are basically help two kinds of tiers, right? We help the entrepreneurs who wants to take an idea and make it into an actual startup by the end of this, and we facilitate quite a lot of building steps in between there. So from starting from a hackathon idea scale that into prototype and then into an MVP through our online programs such as Slingshot, and then also the local program such as Gaia. We're trying to basically help more people get to a point where they can build something themselves. The second track is also that we work with a lot of businesses to basically ensure the same kind of process, but internally at their place. So we're in the process of doing that, and process of basically trying to proliferate more of this technology to the world. That's what that's what we're all about.
Thank you so much, Simon, for finding the time and joining us, even this rough week. And it's always happy to have you with us on the streams. Let me move on with introducing to the partners we have for this hackathon, and not only partners, but technologies that we will use and will have access to use over this 7 days, basically a week event. So we will start with TrueLens by TruEra, and we'll have a deeper intro today a bit later. But for now, what I wanted to tell you that TrueLens is a product by TruEra, and it's basically your all-in-one toolkit that includes TruEra Evol, which is the model for evaluation of your LLM output and LLM-based apps. And then we have TrueLens Explain, which provides you deep learning insights. So with these tools, you can easily enhance and improve the output of your AI applications. Then we have Google Cloud Vertex AI product that will give access to all of the hackathon participants to their ecosystem for this hackathon. So basically, it's your one-stop shop for all the AI-based and AI models that you might need to build for this hackathon. So these AI solutions allow you really effortless AI development of your applications, and they have over 100 foundation models available on the platform, so that should cover all your needs for this hackathon. Then our next amazing partner is Zillis. Zillis is it's the vector database that designed specifically for enterprise AI and for large language models apps that we will be basically building over this hackathon. Zillis will provide you full mentor support, and also we'll have session today with Zillis to explain you how to incorporate vector database into your AI application if there will be a need for your project architecture. Moving on, we have Llama Index, which is also our great partner that will provide you a mentor support for this hackathon, as well as the workshop session, so educational material. And Llama Index is an open source data framework, and it's designed to connect your unique data sources and your powerful large language models that you will be using for your apps. With that, I'm super happy to invite Anupam Datta, that is co-founder, president, and chief scientist at TruEra. And with his opening words, that will be pretty quick, but that will help us to understand what TruEra is and how we'll use it for this hackathon.
Thank you so much, Alicia and Simon, for that kind introduction. We are really excited to kick off this TruEra Challenge Hackathon. We are here to build, and so I'm going to keep my comments short. I think what's exciting from my point of view about this moment in time is that we are at that cusp of that next big technology advance with generative AI. And to build applications that are effective and deliver value in production, it's extremely important to make use of the kind of tech stack that we see in this hackathon. You need a reliable LLM partner like Google. You need a orchestration framework like Llama Index, a vector database like Milvus, Zillis, and you need good capabilities to evaluate your LLM applications, to iterate on them, to improve them, and then to monitor them once they're in production, which is what TrueLens and TruEra more generally provides. So I think this is an excellent opportunity to spend a week building some really compelling applications where the applications are cool, they solve an important problem, and at the same time you can measure the improvement as you go through that iteration process of fine-tuning your applications, leveraging the LLM offerings from Google, the orchestration framework from Llama Index, Milvus, and TrueLens. And this follows, this has been a really exciting week for me. A course that I worked on with Andrew Ng and Jerry Liu on building and iterating on LLM apps, especially advanced RAGs, was just released a couple of days ago. On the first day, we got 10,000 signups, and people are really resonating with the importance of this topic. And the workshops that we have planned as part of this hackathon will really give you a deeper view into some of these core pieces of how to put technology together in a way to build effective apps. So I'll kick off with a session that Alicia mentioned with Google folks on building and evaluating apps. Then we'll have a joint session with Milvus on this topic with a focus on vector databases and how to evaluate retrieval-oriented failures. And then we'll go into, on Monday with Llama Index, looking at agent-based architecture. So you'll see a bit of breadth in terms of RAGs, retrieval augmented generation, but also agents, which are starting to take over. And we will discuss in particular also a bit around multimodal applications, which are an emerging trend. You have seen that GPT-4V has been released. There's a bunch of other models starting to provide multimodal capabilities. So as developers building applications, starting with RAGs, looking at agents, looking at the multimodal models, and building applications on top of that, all with a careful eye on evaluation and iteration to measurably improve your app's quality, and keeping track of cost and performance would be a quick week will get you into the details of that. And I hope it's an exciting experience for all of you. We are super excited to partner with an outstanding set of folks here at LabLab.ai and our other partners to bring this event together. And we're looking forward to your active participation. Thank you very much.
Thank you so much, Anupam. We're excited to have sessions today, and it's really exciting to see how we combine technology at the hackathons to make something really beautiful in the end when it comes to people's project. Really excited to have you joining the hackathon with us. Let me then go and talk more on the hackathon elements, like a challenge, the credits access. I see already a lot of questions in the chat regarding access to Google Cloud Vertex AI credits. So give us a moment and we'll cover all the topics in the stream today. And just a quick note that the stream and also sessions on Monday will be recorded, so you can watch it anytime you prefer and check the sessions again once you will know what you should exactly build, and you will need some more like workshop to rewatch and to have a starting point. So don't worry about the sessions. They will be recorded and will be shared with you via email and on Discord. When it comes to the challenge for this hackathon, so basically the challenge is to build your own LLM-based application. We don't limit you over the industries you want to choose or the specific use cases. We just want you to focus as much as possible on the improving the output of your LLM application utilizing TruEra. And when it comes to the technologies that required for this hackathon, remember that for this hackathon and to be eligible to submit and also be evaluated over this hackathon, you must use TrueLens technology together with Google Cloud Vertex AI products that we will give you access to over this hackathon. We also recommend you to use Llama Index Framework and ZList Vector Database if there is room for these technologies in your project idea in infrastructure. Moving on to the way we will measure your success, which is success criteria for this hackathon. So first of all, your application should have and should cover a real world problem, because it's really important for us not only to learn how to build things with AI, but also to cover a real needs that we have. And that would be amazing if your application can not only be a great use case of TrueLens technology, but also have a real impact on the world in the future. Then it does not have to be production ready, counting that we have only 7 days to build this, but it definitely should showcase some practical usage and usability, and should make users excited on the future developments you want to have with your application. Moving on, that your application has to showcase a full observability suite built in, and also scores highly on evaluation. So please make sure that you focus on the evaluation part and that you will work more on showcasing the improvements of LLM's results together with TrueLens. Also, you are able to tell the story, how you utilize the technology and how you utilize this improvement of your LLM output in your application, in your demo video. So that would be awesome to see your story behind improvement your output. And moving on, remember that you must use two technologies, which is TruEra and Google Cloud Vertex AI. Without these technologies, we cannot count your submission for this hackathon, and your submission cannot be evaluated. That's really important part of the challenge. Now, everybody that will join this hackathon will be eligible to get access to Google Cloud Vertex AI credits. We want to make sure that only people that will be building over the hackathon will get access to the credits. So there is a few ways to get them. So there is two infrastructures that you can use for this hackathon. The first one is your own account that you will create on your email and you can use for this hackathon with credits. And the second one is our own infrastructure that we provide only for hackathon participants. Covering the your own account part. So when people are creating an account on Google Cloud, it's a new account. You're getting 300 credits to start building, and it's kind of booster for you to test out the projects and to get started. And also, in addition, for this hackathon only, if you're providing 30 credits for people that already created or joined a team for this hackathon. So if you are actively participating in the hackathon, you already have a team and you are ready to start your building process, we are providing you 30 credits for Google Cloud services. These credits will be distributed in a few ways over this hackathon. So we'll be monitoring how many people join the team, and we'll be sending out credits to those that join. So if you are working with your team members, just make sure that you're already on the team on the LabLab account. So we will make sure to track if you are part of some teams and send you the credits. That's a very important part. And also speed up your team formation process, because the sooner you will form a team or join existing one, the faster you will get the credits. And also we have our own infrastructure that we provide for this hackathon. This infrastructure is designed in the way that if you already expired your credits or you already run out of credits you had for this hackathon, or even in case you have any troubles with connecting your own account to Google Cloud, it can be different reasons, starting from the location or maybe from the card details that if it will be a problem for you, because we saw a few messages in the Discord server. We are providing our own infrastructure, and here is how to get access to this. So every single team leader that created a team and is marked as a team leader, so you have a team leader role on your team page, you will see the specific form and the component on your team page, which is request access to Vertex AI. Clicking on the request service account, you will get email with instructions on how to join the server account, and you will get your specific access that your team can use for this hackathon. So with this 3 ways, you should be covered. And if you will have still some questions or doubts, please contact us via Discord. For this hackathon, to speed up your building process and also to help you to have a bit of ground when you're starting, we created tutorials specifically on TrueLens and also TrueLens plus Google Cloud Vertex AI products. Feel free to use these tutorials on our LabLab page, and you will be able basically to start pretty quick and to get an idea how to build your own application training with tutorials. When it comes to the hackathon prizes, you might see them already on the event page, and I just will go through all of them to give you an idea what everybody in this hackathon will get as a prize. Let me just quickly see the chat if there is anything I can answer right now. Okay, I see the question regarding individual participation. So if you participate individually, you still have to create a team on LabLab. And you can work solo, just don't allow people to join your team. That's still okay. And since you participate solo, you will be team leader of your own team. So you can already see the access to service account for today's hackathon. And that still should be, like, everything will be covered. You will not have any weaknesses in comparison with teams that have more than 2 members. When it comes to the hackathon prizes, so hackathon prize pool consists of cash prize and Google Cloud credits. So hackathon winner will get $4,000 in cash prize and $5,000 in Google Cloud credits, when second place winner will get $3,000 in cash and $3,000 Google Cloud credits. Third place will get $2,000 in cash prize and $2,000 Google Cloud credits. And also 2 more finalists of this hackathon will get each by 2,000 Google Cloud credits. Furthermore, the teams that will submit their solution over this hackathon, and the submission will be eligible. So the submission will consist of 2 technologies, which is TruEra and Google Cloud Vertex AI. Will get 100 Google Cloud credits per each team member on top. So if you're making submission, your team will get 100 Google Cloud credits per each team member, which is pretty great for you to continue your journey. Let me move to introduce you to the mentors we have for this hackathon. So I'm happy to introduce to you our mentor leads. That's not all the mentors. We have way more mentors on our Discord, and you might already know them. They are technical and business mentors that will cover you across different time zones to make sure that you have all your answers and you're ready to build over this hackathon. So we've just met Paolo, Muhammad, Donald, Theodore, Shabadi, and most of you know him as Kudos and Vola. They are our mentor leads, and they are leading our community to make sure that you're covered with all your needs. Don't hesitate to reach out to them if you have any questions. Now it's time for me to guide you through the platform, and then we will be moving to the sessions for today. So let me just briefly go through the hackathon process and how it will look to you. And after, I will show you how to navigate on our lablab.ai platform live. So we are starting from creating your team. So after this kickoff stream, we will start the information process, during which you must create or join your team for lablab.ai. It's a must-do step, because if you don't have your team, you are not able to do submissions. So it's really important for you to start with this step, and then you can collect your team members and your team to continue building. But having a team will secure you the credits access to our infrastructure, and proper support. So just make sure to do that, and then it will ease our communication and easier way to get the credits for this hackathon. After you will create your team, you will meet your team members on Discord, and I will show you how to create your channel. Afterwards, you have to have discussion with your team and come up with 2-3 concepts of your application, of your idea for this hackathon, and discuss it with mentors. After you will get OK go from mentors on one of the concepts, you can work on your prototype over this 7 days hackathon. And in the last day of the hackathon, you must submit your application on lablab.ai to your team page, and I also will show you how to do so. Okay, let me just quickly go through what we have in the chat. Yes, I said that almost all the questions are covered. You must create your team because it will ease our communication, so all the rest should be all right. And let me know if you have any questions regarding credits access still, and I'm happy to cover this now during my showcase. Okay, then let me show my my platform screen share. You should be able to see everything now. So that's our hackathon page, and it's a one-stop shop for everybody that will be participating in the hackathon. All the information regarding TrueLens as a technology and resources, as well as Google Cloud credits access that you can find right here, challenge description and the prizes. Then the success criteria that I just talked about, technologies that you have to use, startup guide, everything is covered here, as well as the hackathon schedule. So make sure to come back to the event page. It will be just easier for you to navigate over this hackathon. Then let's click on the button, create or join your team, which helps us to go to our participants dashboard. Here you see the instructions that you need for this hackathon, with links to the hackathon guide, getting started guide, AI tech pages that you need for this hackathon. Everything is here. So when you scroll down, you have a button to create your new team or join existing one. I will cover and show you how to create your team before, but let's just let's just take a look on the team list and how you can join a team if you don't want to create one and be a team leader. So here you have a list of all the teams that are over this hackathon. So you basically see them all right here. You can click and just check their ideas and join anyone you want. Join a team, you should look for the team was looking for members button. So there you can just quickly join and say that you want to join this team, join a team, and you're in the team already. Now you can sort them by the number of team members, by the time zone to pick the best time zone for you. And also you can choose your expertise to see what actually people at this hackathon needs. That will be helpful for you to choose the best team that you have. Then we go to create a new team if you want to be team leader, work solo, or just want to collect members. Let me just quickly create a, I have some drafts here. So the team name. Okay. Then we go to the description. That's really important. Description is a very important part because with description, people can have an idea what you're going to build, so they will know is it okay for them to join your team or not. Then if I'm looking for members, I can click here and pick expertise I'm looking for, let's say this, and then I can upload an image. If I have one, if not, it will be automatically generated. I'm creating my own team, and now I'm team leader of the team. Sorry, I guess it just took me to another team. Here we go. That's my team. So what I want to do right now is to show you, wait, that looks really weird. It's not my team. Let me join an existing one. Or maybe I will refresh the page, it should help. For some reason, keep just giving me another team link. Okay, again. That's great if we notice just now, so it will be fixed before you will start working on your teams. So to give you an idea, I still need to have a team leader role to be able to join. So let me just still refresh the page and try it again. That feels really strange. Okay. Since I cannot be team leader of my own team, I cannot show you the slide that I wanted, but basically all the functions is visible here. So in your team page, you have ability to see how many times still left for your submission. Then you can see the submit your project button, which will allow you to submit basically your solution. When you click here, you see all the input parameters that you need to input to submit your solution. After that, you have the list of your team members, and I don't want to deactivate my team, so I want to show you one button. Let me try to join maybe another team. Still same. Okay. Maybe some of this team. Perfect. So I can see the list of all the team members. And after that, there is a join a team channel. So after you have more than one team member in the team, and that's basically the reason why I haven't seen it before, because there was only one team member. So once you have more than 2 members in a team, you see join the team channel button. And if I would, when you click to this channel, you basically see the channel of the team and their communication, and you can communicate with your team members there because they will be added automatically. And also here, if I would be a team leader, I could see the component that I showed you before in the presentation to apply for your Google Credits access that you will see having a team leader role. And if you will have issues like I just had with access to the team page, feel free to let us know via Discord. Let me stop my presentation. And that should be it. And coming back to the presentation we have now, that's all when it comes to the platform walkthrough. And again, if you have any questions, let us know in the Discord, and this session will be saved to help you navigate through the information process over this hackathon. And now, finalizing everything, I'm happy to come back to the workshop part where we can already see what we will be building during this hackathon and get a bit of experience start and have a ground for us to start our projects building. And I'm excited to have today with me Michael from Google. He is the customer engineer at Google, and Anupam Datta, that you already know, he's co-founder at TruEra, and they have a joint session about Google Cloud and TruEra workshop, and it will be mainly focused on enhancing LLM outputs, taking as example Palm to LLM. So I'm happy to welcome Michael and Anupam, and the stage is yours, guys.
Thank you, Alicia, and yeah, let's get started. This workshop is on building and iterating on LLM applications, leveraging Google capabilities and TrueLens for evaluation. And without further ado, let me hand it over to Michael to get started on how to build applications with Google Cloud. Over to you, Michael. You might be on mute.
You're muted, Michael.
There we go. Forgive me for that. I am not yet a Discord expert. Let me try one more time to share my screen here. Or am I shared already? Okay, there we go. All right, and you can see my screen all right?
Yes.
Okay, great. Thanks so much. Nice to meet everybody today. I'm Michael Davis. I am a customer engineer for Google Cloud. It's my job to help all technologists like all of you learn how to use Google Cloud technology to help your business be more successful. I spend a lot of time talking about all Google technologies, but in particular lately, it's been a lot of generative AI, as I'm sure you all are aware. It's become quite exciting in that world these days. So with that being said, what I'd like to do is just walk you through some high-level slides that show kind of what the Google ML and generative AI ecosystem looks like. So let's start with the broadest view. Over on the left, we have our foundation models. We'll come back to most of these areas in a little bit, but basically we have foundation models that have been trained on very large amounts of data to solve a variety of different use cases and form the basis of
So I guess, Michael, one quick comment is I don't see the stream. Do you, Alicia? Is it working for you?
Yeah, we do. There is a screen. Watch the stream. We know you should.
It's
How do we say this?
working now.
Mhm.
Yeah.
Okay,
Sorry
can you see my?
Please.
No, that's okay. Everybody can see my slides though.
Yeah, yeah, we can.
Yes, we can
Okay,
see it
all right.
now. I just didn't want you to be talking about it. So please go ahead.
Okay. Okay. Yeah, no, that's fine. Yeah, we'll sort that out. Okay, so in any case, foundational models on the left, they power the higher level constructs within Google Cloud that build on top of those foundational models and bring them to you in a variety of different ways. In the middle now and at the top, we have more of our consumer hobbyist type experiences, which will be a bit out of scope for today. And frankly, most of what I talk about isn't that stuff. That's for your, billion, users all over the world that want to go to Bard and ask a question or something like that. That's not all of us. We're developers, we're technologists, we build things. And so we'll be operating on these, lower level constructs. In the very middle of this diagram, it's more like application level integrations of generative AI. For example, generative AI within, let's say, Google Sheets to help you make a spreadsheet, or Google Docs to help you write your term paper or something like that, right? Once again, probably not in scope for our conversations today. Although they do actually come up in some of my enterprise level conversations, because a lot of folks like to use Google Workspace for their business, and they would get value from those things, but they're not builder tools where we will be spending our time. So that brings us to the bottom then, which is Vertex AI. Vertex AI is our end-to-end machine learning ops platform that includes generative AI, and that's what technologists like us will use to build our internal and external products upon. Within Vertex AI, there are a variety of different models you have to choose from, and they're broken down on a couple of different axes. So one is the purpose of the model. So maybe it's for text or code or image generation or something like that. You can see that in that kind of green example off to the right there, text bison. Text is what that model is used for. Bison gives you an indication as to the size of the model. There are 4 different sizes, gecko, otter, bison, and unicorn. Not all of these are directly exposed to the general public, but depends on the use case. So there are mostly bison models and then a few gecko models, gecko being the smallest ones, that are available. So it might be like text bison or text embeddings gecko or code gecko or something like that. And then the third dimension of the model is just which version it is. So is it version 1, is it version 2, and so forth. Okay. So with that said, now let's look within Vertex at kind of the vertical orientation of these things. At the bottom, it's our proprietary infrastructure that I think is a major differentiating value for Google, particularly with the tensor processing units. We do have a very large fleet of GPUs, NVIDIA GPUs, that you all can leverage, but then also for optimizing the training and inference of the very largest models, we have tensor processing units, which are proprietary Google technology and make that much, much, much faster. Okay, on top of that, we've got our foundation models, and these are things that AI practitioners and you all will use. So the foundation models exposed through Vertex AI, through an API layer. That's where you'll maybe write Python code or even just use, curl or something like that to make direct API calls and build the product that you want to build down at that kind of AI practitioner level. Over and above that, we do have kind of packaged solutions for common use cases that are, let's say, 90% complete. So for example, if you're building a retrieval augmented generation style enterprise search type application, there's a lot that really goes into building that out from kind of a plumbing perspective. A lot of things that you have to figure out how to do that are not immediately obvious. And hey, Google knows a thing or two about search. We've done it before. You may have heard of that. So in any case, we bring that experience to this enterprise search platform within that. And you as a developer then have all the plumbing done, and you then have an API you can just plug into like your user interface or something like that. So you might have some kind of a JavaScript web page, and you just plug that in and you're good to go. So it's not a fully complete product, but it's basically like the engine of the car is built for you already. And then, like I mentioned, there's a higher level for business users where we're integrating it through Duet into like Workspace and Google Cloud or Doc AI, where it really is a complete product and there's really no development required at all. We're going to be spending our time on that blue layer toward the bottom. Just a final word about the different types of models that we have. Certainly PaLM for text or chat. We've got Imagine for text to image generation. We have an embeddings API you can use to create embeddings. You can use Chirp for speech to text transcription. And then what I find incredibly useful these days is actually Cody for code generation. We'll touch briefly on that in my demo in just a moment. And with that said, let's get into that demo. Okay. So now what I'd like to do is show you, once you're in, and you can still see, you can now see my Google Cloud Console tab, right?
Yeah.
Groovy, thank you. Okay, so you've got a GCP project. I'll leave that to you to figure it out. But once you've got your project, maybe you got some credits or what have you, you're in there, you're in the Google Cloud Console. Now what do? Top left-hand corner, there's a little menu over here. You'll dig in to find Vertex AI. It's actually pretty far down the list, but I've pinned it up top just for convenience now. You can start on the dashboard of Vertex AI, but very quickly, what I want to do is actually go to Workbench. So if you're following along when you come back to do this later, you will want to make a pit stop in Workbench and create a new, and there are several types. I use the instance type frankly, it's just kind of simpler. It deploys a VM running Jupyter Hub. So that's what I'm going to do. I'm going to click Create New. I can pick a few different settings. I can pick the size. I can attach one of those NVIDIA GPUs, like I mentioned, we've got a bunch of. So we could do that, and then we'll click Create, and then I've got my work, my Jupyter Notebook VM instance that's going to spin up. Once that's done, I'll click Open Jupyter Lab, and that will pop me right over here into my Jupyter Lab UI. Okay. Let me actually even start a new one of these. Okay, so now I'm sitting here and I'm like, okay, I've got my Jupyter Hub. I want to use Gen AI. Now what do I do? And this is where I like to actually go back and forth between the UI and my Jupyter Notebook. And why is that? Well, in order to build a product, we're developers, many of us are, we're technologists, we want to write some code, but having a UI is a nice way to bootstrap that process. Let me give you an example of what I mean. I just clicked into the text model area, and I'm just going to ask it. It's like it invites me to prompt it, right? So I'll be very brief here. Give me a vacation plan for Warsaw, something like this. Type that in, click submit. I don't really care what pops out of here. That's not the point of what I'm after. What I'm really after, and notice, by the way, I have a variety of models to choose from. What I really want, though, is up in the top right-hand corner, there's a View Code button. And it gives me the Python code I need to bootstrap myself. Now, I can just copy paste this. I can actually also just go open that up in a collab, or even see this if I was writing native curl commands and I didn't even want to use the SDK. I just want to call an API. I can do that RESTfully. But anyway, so I'll grab my Python code here. I'm literally just going to copy that. I'm going to paste it right over here, run it, and we'll see we get responses. And the reason why this is so powerful is I didn't have to go spend an hour reading API docs to figure out what to type in here, right? If I've never used the Python SDK for GCP before, it would have taken some time. But now, boom, copy paste, I'm good to go. I got a response. Now I can go fiddle with this and make it look the way I want. For example, I might want to do multi-shot prompting instead. So once again, though, instead of, okay, we know what multi-shot is. Here is the prompt. Where is that? Here is my prompt I put in. Now I could go in there and type in a whole bunch of multi-shots into that prompt. But let me show you the power of having actually in here a prompt gallery. You can, so whatever you put in to that UI, you can actually save that as a prompt to come back to later. And here's some examples. Now, in this example, I'm going to open this up, and this is just using a multi-shot UI helper thing that allows you to put in as many shots as you want. In this example, we're doing some hashtag tokenization. And what that's going to do is actually, it's just a wrapper around this text prompt, right? But I can put it in, and it structures it nicely for me. And then when I go to view code, you can see here is the new prompt. It's still just like any prompt, it's still just one long string literal, but it did help me kind of organize that and kind of put it together. And now once again, I can just copy this code, drop it over here into my notebook, and then just run it and get a response back out of that. Okay, so I would recommend that you do that as well. Choose some different models, try chat. Let me show you how to get to chat in the UI as well. So in language, you can choose whether you want to do a text or code prompt using the kind of the non-multi-turn, the single turn text model, either text or code of single turn, or you can start a conversation, either a text or code conversation with the multi-turn chat tuned model. And all of that is controlled with a variable. When you're in your code, there's a variable that actually sets the model that you're using there. Okay, so I would recommend play around in the UI, then view code, copy the code into your notebook, and you'll be good to go. Okay, thanks very much. I'd like to turn it over to Anupam to carry us forward here to the top of the hour. Anupam, are you ready?
Great. Yeah, thank you so much. I think if you stop sharing, then I can start.
Okay, I think I have I stop streaming. I think we're good.
Perfect.
Thanks, everybody.
Awesome. Thank you for that quick introduction, Michael, to Google Vertex AI. That would be a great place for our participants here to start with. What I want to transition into is, as you start building your applications, it would be valuable to start thinking about how to evaluate them. What are some of the failure modes? When I started thinking about this problem some time back, I decided to do a scientific experiment. And that scientific experiment involved doing a vanity search. I went to Claude, in this case, asked who are the founders of TruEra. This is the answer that Claude came back with. So the interesting thing here to observe is that it did get the structure of our founding team right. There are three co-founders. Two of us come from technical and research background. The third founder has a significant amount of industry experience. But it also got a lot of specific facts wrong. It got my name right, but our second co-founder is Shaikh Sen, not Somesh Shah. Shaikh will be speaking at the workshop with Llama Index on Monday. He's been a big driving force behind TrueLens. He's also one of the mentors. You'll get to meet him. And then our CEO is Will Uppington, not Tomer Geva. But this is very representative of how large language models work. And in some cases, they're expected to do that, which is to get the general facts, the general trends right, like the structure of this founding team. But it's not so great at memorization. We have been training these models to generalize, not to memorize, and that's evident in this example. But this raises a significant challenge that LLMs, you should consider them to be hallucinatory unless proven otherwise. And that's where a lot of applications get stuck in moving from development into valuable production-grade applications. So in order to address this challenge, we introduced TrueLens. TrueLens is an open source library to evaluate and track your LLM experiments as you're building your applications, let's say with Llama Index or with some of the Google Cloud capabilities. You can connect it to TrueLens with just a few lines of code. We'll show some notebooks shortly. And it can log the prompts, the responses, the intermediate results, as well as these abstractions of evaluation that we call feedback functions, which can be used to detect various kinds of failure modes around hallucinations and more. And then you can explore it in a dashboard, see where the failure modes are, iterate on the application, and then improve it, and then go on to pick the best LLM chain. And there are very nice integrations with Llama Index, with LangChain, and so on. So it's just with a few lines of code, you can get going very rapidly and then see the results of evaluation. I'll spend maybe a minute on this slide, like under the hood, how are these evaluations being done? And more broadly, how are people, developers and teams that are building out these kinds of applications, how are they going about evaluating them? Often the starting point is ground truth evaluations or human evaluations, and they're very meaningful, but they are hard to scale. It's okay if you have, say, of the order of tens or hundreds of evaluations, but once you start getting into serious app building, you want to run them over tens of thousands, millions of records, and evaluations then become extremely important to scale up with automated programmatic evaluations. And in that space, you have support for traditional NLP evaluations, but also LLM-based evaluations, which tend to have strong agreement with human evals, but can be expensive. Then we have evaluations based on more medium-sized language models, such as bird-based models. So as you're exploring this space, under the hood, you'll see we have within TrueLens, there's support for all of these kinds of evaluations, but you'll also see in particular quite a bit of emphasis on evaluations that make use of large language models and medium-sized language models. That's something to play with as you are going about building and evaluating your applications in this hackathon. Let me give you a quick example of one kind of way of testing RAG-based applications for hallucinations called the RAG triad. The RAG triad, as the name suggests, has three endpoints. There is the query, then the user comes in, asks a query. There's the set of retrieved pieces of context from the vector database, which could be, say, Milvus. Then you get the final response, which is summarized by an LLM, such as one of the Google LLMs. And along each edge of this triad, there are some tests or evaluations that you want to do. Context relevance is checking, is the retrieved context relevant to the query that was asked? Groundedness is checking, is the response supported by the contexts, the retrieved pieces of context, or did the LLM make stuff up here, which is often the case. So this is an important step of guarding against hallucinations. And then finally, answer relevance checks that the answer is relevant to the query that was asked. And the implementations of these evaluations is done using large language models, medium-sized language models. So let me give you a couple of examples, and then I'll show you a notebook that can help you get started. So in this case, we put the TruEra website, chunked it up, put it into a vector database, and we asked who's Shayak, and it came back with this response. Now, if we look at the set of retrieved context, which ultimately was summarized to produce this response, that gives us insights into how much of this response is accurate and where the failure modes are. So there were 4 pieces of retrieved context. The top 2 were actually about Shag. The bottom 2 were not about him. It was about a different person in our company called Shamik. And because the final response involves summarizing all 4, in this example, the first 2 sentences are accurate. They're truly about Shag. The last sentence is not. That's a sentence about Shamik, which got pulled from one of the lower contexts that were retrieved. But through the automated evaluation in TrueLens, we are able to give these contexts a score on a scale of 0 to 1 that indicates how relevant is this context to the question that was asked. And you can see that it correctly identified the top 2 as relevant, the bottom 2 as not relevant. And so this suggests a mitigation, which is after doing this kind of evaluation, you can filter out the irrelevant pieces of context and only send the relevant ones to the final LLM for summarization. If you do that, then you get a better version of the app, you iterate on the app, and the last sentence goes away, and you only get information about Shag. So this is something measurable that you can see through the evaluation. So at one version of the app, it had certain kind of context relevance or question statement relevance scores. You understand the failure modes, you improve the app through this kind of context filtering. In the next version of the app, those metrics go up. That's the kind of exercise you want to do when you are building your apps and evaluating them in this hackathon. There are a couple of other examples I'll give you. This is groundedness. Groundedness is super exciting. It's very interesting and relevant. So in this example, it's a call transcript between a person in a hotel, a guest at a hotel, and customer service there. And then this is summarized from that, is a summary of that call produced by an LLM. And over here, you can see that we have groundedness evaluations where for each clause or statement in the summary, we are figuring out how grounded is it in the original call transcript. So on the right here, you can see that for the first clause and the third clause, there is good evidence, supporting evidence in the original call that backs it up. That's why on a scale of 1 to 10, they get good scores of 10. But the middle part, there's a statement about they're not happy about the weight. And for that, there isn't good supporting evidence. And so it gets a low score. So this kind of groundedness evaluation can help really separate out which parts of the final summary or the final response can be traced back to the retrieved pieces of context, or if it's a simple summarization application, not a RAG, to the original parts in the documents. This kind of traceability is incredibly important to guard against hallucinations. And this can then get built into larger workflows with humans in the loop who can look at these when there are issues and address them appropriately. So this is another hugely interesting area for you to explore, the groundedness evaluation in the RAG triad. And then finally, answer relevance is giving scores on you ask a question, you get better response. How relevant is that answer to the question that was asked? And for each of these, there are implementations using large language models as evaluators, which you can play with. It's a good place to start. But there are also some implementations using medium-sized language models, leveraging things like natural language inference, which you could also look at if you want to go deeper. These are just examples. The RAG triad is a good place for you to start when you're evaluating your applications. And just coming out from teaching a quarter-long course at Stanford, where students worked on quarter-length projects. And in that project, at the end, a lot of it was focused around evaluations, and many of them worked with the RAG triad and augmented in various directions. There's a whole bunch of other evaluations also in TrueLens. This is a partial list here that you can play with. You can also add your own custom evaluations. So often when you're thinking about your own applications, it's valuable to add additional evaluations. It's easy to do that. So let me show you very quickly a notebook, and this is available on the Discord channel. How to get started. It's a quick start. So you authenticate to the Google Cloud Platform. And there's a part of the partnership here in the hackathon is that we are now leveraging the LLMs on Vertex AI to do the evaluations, and also to potentially build the LLM applications as well. And here's the QR code if you want to take a quick picture. The deck and such will also be available. The notebook is already on Discord, so you can find it there as well. But once you authenticate you create your Google account, you authenticate to the platform, you set up a project, and then you import LangChain and TrueLens. This is a very simple LLM application. It's just going to answer a question using an LLM. And then you send your first request. What's a good name for a store that sells colorful socks? You get back the response. And then this is the interesting part where, by the way, here when we are setting up the LLM applications, we are making use of Vertex AI as the LLM that's used to answer these questions. This is the evaluation section, which is interesting. You initialize this feedback function where we are using Chat Bison, which is one of the models that Michael talked about earlier, as part of the evaluation. And then the relevance function here, this is the answer relevance function. It'll also give you the answer like a score and evaluation of these kinds of things. Then you can instrument the chain for logging with TrueLens. And then finally, you can explore it both in a dashboard or view the results directly in your notebook. So for this particular question and answer, you can see the relevance score was 0.8 on a scale of 0 to 1. Latency was about 1 second. The total cost was negligible. That was a very quick overview. In the next workshop, which will start momentarily, we'll go deeper. So please join Josh from TruEra and Eugene from Milvus in that session. So let me pause here. We are at time. Thank you again for joining us on this hackathon. It's going to be awesome. And thanks, Michael, as well. It was good to tag team with you. And I hope people have a lot of fun building with Google and TrueLens.
Yeah, likewise, Anupam. It was my pleasure. Great to meet everybody today. And certainly reach out to either of us if you'd like to follow up on any of these topics.
Thank you so much to Anupam and Michael. That was really a pleasure to have you all today together working on one session. And thank you so much for joining the session today. And moving on, we have one more workshop for today with Zealous and TruEra, and we already have our speakers, which is Eugene Tang, he's developer advocate at Zealous, and Josh from TruEra, he's the real engineer. Happy to have you all. I see Josh and Eugene. Perfect. If you are ready, you can share your screen and kick off the session.
Awesome. Thank you, Alicia. And really awesome session from Michael and Anupam. It was a ton of fun to see all the different ways you can use Vertex and TruEra in concert. So in today's session, we're going to be talking about how to build and iterate with advanced index construction. And I'm really excited to be joined today with my great friend, Eugene from Zealous. So I'll pass it to you, Eugene.
Hey guys. Yeah, I'm really excited to be here. Thanks for inviting us to be part of this, Josh.
Awesome. Yeah, glad you're here. So I'll leave it to you to kind of introduce Zillis and then get into some of the key reasons we're here today, and then we can go forward from there.
Yeah, so I think we're mostly here to talk about RAG today. We're going to talk about some of the basic concepts as well as some of the more advanced or pre-processing concepts, things that you should consider as you are building your RAG apps. I'm a developer advocate at Zillis. So Zillis was founded in 2017, and we're currently based in Redwood Shores, California, right in the Bay. And probably the most important project you want to know in this list of open source projects that we maintain is Milvus, which is our vector database. So the basic idea behind RAG is that you want to use your data with a large language model, and they don't have access to your data. So there's two kinds of, I guess, approaches that people typically take when they think about how do I incorporate my data with a machine learning model. And RAG is a relatively, I guess, newer, more recently popularized approach. It stands for Retrieval Augmented Generation. And the idea behind it is that you are basically injecting your data on top of the large language model using a database, vector database like Milvus or Zillis. And then you can see that in this lower left-hand corner here, there's this little diagram that shows you what's going to happen. So essentially, you take your data and you put it into Milvus, and then the LLM interacts with Milvus. And when the query comes in, the query goes and it says, okay, let's see what we should actually be asking, vectorizes the query, and then it goes to Milvus, asks the question, and the LLM turns that, or it goes to Milvus and it pulls the most semantically similar data, and the LLM turns that into a human-readable response, and it gives it back to you. And the primary use case for RAG is basically if you want to enforce factual recall, if you want to force data injection, and for cost optimization, specifically for things like semantic caches and production.
Awesome. Yeah, RAGs have been a game changer, especially in the beginning when we were limited to kind of models with really small context windows, and we had kind of huge sets of facts that we needed to pass. It's maybe useful to touch on a bit as we've seen models to start to really expand to really big context windows, 100K, 200K tokens. Why should people still use and care about RAGs?
Yeah, so that's a really good point. This is something that I've seen around the internet as well. Claude now has the 100K, 200K context windows. So here's the thing. Yeah, these context windows are great. Like the size of the context window is great, and it's good to be able to have more context. But there's a couple drawbacks, and one is something we've seen in LLMs for I guess a while, at least around a year now, is that they are still. They have this tendency to focus on context that comes at the beginning and the end, and they skip the middle. And so this actually is also something that comes into chunk sizing as well. But the other thing is 100K or 200K tokens is really not that much. Like when you think about how much documentation you have at your company, I guarantee you have more than 200K tokens.
Yeah, for sure. Great point.
Yeah. So the other thing that people the other way, I guess, that people use LLMs, they use their data with LLMs to fine tune. And fine tuning, the idea behind fine tuning is you're augmenting the LLM. You're changing some of the weights and the biases in the LLM. And the way you do that is you train your LLM on your data, and then this creates a new LLM, and then the query interacts with a new LLM. The drawback from this is that the query never really gets to see your data. But the primary use case for this is a style transfer. So essentially, the way you can think about this is it's as if you were adding a prompt at the beginning of the context window that says, hey, answer questions like this or use some context like this. And the reason why this is good for style transfer but not factual recall is the LLMs are trained on probably more data than you have. I would say that maybe you have 1%, 0.1% as much data as the LLM is trained on. But for things where it doesn't see as much, for particularly things like maybe newer classes in a sense, it does offer that ability to answer questions in a specific manner. So the takeaway from the last couple slides is basically use RAG to force the LLM to work with your data by injecting it via a vector database like Milvus or Zillis.
Sweet. Yeah, so as Eugen just introduced, when we think about the kind of typical architecture of a RAG, you're just going to start off with your kind of user-based question or user-generated question, and we're going to generate some embeddings from that, and then take those to our vector database like Milvus or Zillis, and retrieve the most relevant chunks. And there's a whole bunch of different choices we'll talk about later on how do you construct a vector database, how do you think about the retrieval. But basically, when you get to those retrieving those context chunks, you're going to pass it back to your LLM, and then your large language model is going to use those in its context window to then generate the response. But there's a huge set of problems we can run into in the retrieval portion. So sometimes when we do this retrieval, we'll get irrelevant context, things that aren't actually related to the question we're trying to ask, and other times we also just don't get enough context. So it's kind of a pretty hard problem to like verify and retrieve exactly the right amount of context that we need to answer a question. And this is kind of the reason we built TrueLens. As Anupam mentioned before, TrueLens is an open source project to track and evaluate large language model experiments, and this is really valuable in verifying and understanding how well our app is performing, how well our retrieval is performing. Are we retrieving the right context that we need for our app? And one way people do this in particular is what we call the RAG triad. So if you think about kind of the three nodes of the RAG architecture, the query, the context, and the response, you can think of evaluations lying on each edge of that diagram, where we have context relevance, groundedness, and answer relevance. And using the three of these, we can evaluate and understand where and when does hallucination occur. So if we think about a few examples or failure modes where we've seen this happen, here we built a RAG with some insurance context, and we asked it how much in losses does fraud account for in P&C insurance. And you see, based on the LLM response, that the LLM was not given the context it needed to answer this usefully. And if we go down to the screenshot from TrueLens at the bottom, you can see each of the context chunks that we retrieved, and along with the scores that show that they weren't relevant, and some human chain of thought reasoning to understand that these context chunks are not actually relevant to the query. We can also see other problems where we have lack of groundedness, and this calls back to our issues with providing irrelevant context to the LLM. So here, we asked this question around the requirements for long-term care insurance. And you see statement 1 and statement 2 are actually supported. So they had context to back it up that were retrieved from a vector database like Milvus. But then statement 3, you see this medical necessity or certification by a doctor is not supported by that context. So this is a pretty clear example of hallucination right there. And what this leads to is there's a huge configuration space when we think about constructing our RAGs. And so starting kind of from the end and then working backwards, when we think about the model, we have to choose which model do you use? Do you use kind of a bunch of different open source models? Do you use something proprietary? How do you choose the parameters? Model size, logit bias? Do we want to use function calling? All that kind of stuff we have to choose. And then in the retrieval, we also might we need to choose how many chunks do we use, what sort of retrieval method, how big should the chunks be, what is the chunk overlap, should we use re-rankers or context filters. And then last, when we're constructing the vector database, we need to choose the embeddings, choose the data, select the distance and index type. So there's just a ton of stuff we need to choose there. Maybe I can go back one and let Eugen weigh in on kind of some of these choices we need to make.
Yeah. So with putting your data into vectors, and as well as retrieving into a vector database, as well as retrieving your vector data from a vector database, one of the most important things you need to keep track of is your embedding selection. you need to make sure that at least the embeddings models have the same size. And typically you want to use the same embedding model to take the data that you want to embed and store in your vector database. That's your, your private data, as well as the queries. And then when it comes to actually storing your data in the vector database, there's also a lot of customizability there. There's an index type, things like HNSW or scan or IVF or quantization. And we'll touch on that a little more later, as well as distance metrics like L2 or cosine or inner product. And then there's data selection. What kind of data do you actually need to store with your vectors, right? So typically you want to store some metadata as well as the text that you actually need, maybe some links that you need, maybe the author, maybe the publication date, maybe the organization that owns that document, things like this.
Awesome. Yeah, definitely hugely important. I think the tons of people really care about kind of including some of that metadata that enables really awesome things like citations and things like that.
Yeah.
And just to touch on briefly, so this is kind of identifies one of the key use cases of TrueLens is as you're making all of these different selections, TrueLens gives you a platform to do the experiment tracking you need to understand which version of your app across all of these different decisions is going to be the most performant. So I'll pass it to Eugen here, but just as you start to kind of get through this next section and you start to think about the project that you're building for your hackathon, it's useful to think about the style and what your data looks like that you're rebuilding. So just try and keep that in mind as we get through this next section to inform some of the ways you're going to be thinking about these decisions.
Yeah, so that's a really good point, Josh. So here I've just put some examples of what your data might look like. And so a lot of people will ask me, how do I get my data into a vector database? How do I select an embeddings model? Things like this. And my response always is, well, it depends. It depends on what your data looks like. And so here's some examples of things like conversation data, which might come in like, just line by line. Maybe this is a support conversation. You are chatting with someone who's working in support, and in that case, you're gonna want to chunk your data up, and you're gonna care about the chunk size. You probably don't need a large chunk size, and you're probably gonna also want to use specific character splitters to split your data. Maybe there's like specific ways that the sentences end in the text, maybe like /n/n, like a double new line. And you're probably not going to care too much about chunk overlap, but when it comes to metadata storage, you probably want to store the question and the answers together. And then there's like document data. And with document data, you probably want, bigger chunks because these typically come in paragraph formats. And what you would want with this is you want to be able to, you want to have the text, but you also want to have some chunk overlap. You want to have some context of the chunk that comes before and the chunk that comes after. And so with this, you're going to care about your chunk size, but you're also going to care about your chunk overlap. And maybe you care about document splitters a little bit. Maybe you want to end, maybe every paragraph is also separated by something like a double new line, or maybe there's tabs at the beginning of paragraphs or something like that. And then the third one that I put here is a lecture or Q&A kind of data set. So this would be something like if you have attended a panel talk or a Q&A discussion and you want to chunk up the transcript for that, you're going to have shorter questions and probably longer answers. And in that case, you're going to care about definitely the character splitters. How do I split my text up? But you're also going to have to think about, okay, like, how long should my chunks be, and what is the overlap that I need? Do I need to have enough context overlap to grab the questions before? Do I need to just have overlap with the chunks before? Do I need to have all of the answer in the same chunk? Because some answers are going to be longer than others, and you also don't want to have multiple answers in one chunk. And so that's also another part where the character splitters are going to be really important.
Awesome.
So yeah, the chunking considerations I just talked about were right there.
Yeah,
So let's walk through an example.
Yeah.
Let's walk through an example. So this is an example that I did with LangChain and Zillis, and basically this is all 5 examples, and we'll kind of cover each example one by one. So let's start with 32.4 example.
Oh,
can
yep.
you go to the next slide? Yeah.
Yeah.
Okay. So here, 32.4 is a chunk size of 32. That means 32 characters and an overlap of 4. And the question that I asked, so this document was a document on software engineering levels. And the question that I asked this document is, what does it take to be a distinguished engineer? And you can clearly see that at 32.4, it is not giving me very good examples. It is not giving me very good responses back. Oh, and I also use a character splitter in this one. The character splitter I used was /n/n and a double new line. And that is because that was how the different sections were split up. But you can clearly see from this that this is not enough of a chunk size. So moving on to the next one, at 64.8, we can see that we're starting to get a little bit more of something like a complete sentence, right? But we'll still see that, like, it still comes back and it's just like looking for the word engineer, basically. And we'll see that we have one example here, which is actually applicable to what we're talking about, which is Werner Vogels, who's the CTO of Amazon. Moving on to the next one, when we have 128 character chunks and 16 characters of overlap, we start to see more complete sentences here, right? So we start to see more things like has achieved noteworthy technical professional accomplishment while working as an engineer, everything a senior staff engineer has, plus generally 15, 20 years of experience, things like this, provides solid technical leadership beyond the company, and then once again, it mentions Werner Vogels. And so this is, can we go back? So this is actually pretty good. So this is, if you look at the document, if you look at the actual text, I should have a link for that somewhere. This actually covers a lot of what's on the distinguished engineer chunk. But we're also testing 2 more. So let's take a look at what some of the bigger chunk sizes look like. So when we get to the 256 one, we've asked the vector database to return 4 examples back, and we start to see that there's a little bit of overlap here, and there's a little bit of less relevant responses coming back. So you look at the last 2, they look very similar, but the last one is actually not as relevant. As Josh was saying earlier, relevance is also very important for RAG. The last one is not as relevant as the one before it. And we're starting to get kind of almost too much text back. But why don't we look at the 512 example and see what that looks like?
Oh, looks like we made lost it.
Okay, well, there is a 512 example, and it is in another set of it's on the blog. I did a chunking with LangChain blog. I can drop a link to that later. But the 512 one will show you that you can actually get all of the responses that the 128 one returned. And so, but you get it in one block. And so the takeaway that I want to kind of show with this is that your chunking strategy isn't just going to depend on what your data looks like and what you need from it, as what your data looks like, as we talked about earlier, but also what you need from it, because you can get the same responses back depending on how you adjust the parameters. You can get all the information you need back from both the 128 and the 512 chunk size.
Awesome. And I'll just kind of combine that with this other takeaway that, like, by understanding some of these decisions and what your data looks like and what you need, you can also kind of evaluate how that impacts that retrieval performance and that final response with evaluations. And then from there, we can get into some of the decisions we can make around distance metric selection.
Yep. So distance metrics are a way to measure how far your vectors are from each other. And so there's cosine, inner product, and L2 or Euclidean distance. These are the 3 distances that we use for dense vectors, which is typically what vector embeddings are. And I guess the most important thing to note is that no matter which one of these you use, they actually all return the same rank order, which means that if I have 3 vectors back, no matter what I use for cosine, inner product, or L2, they should all come back in the same order. So I'm going to cover just what these little, what are they called, equations are here. So cosine, you can see, is a bit complicated. Cosine is a bit complicated. It's a dot product divided by the 2 magnitudes of the vectors. And this is a lot more calculations. And typically cosine makes the most sense when you're working with normalized vectors, but you can also use this on unnormalized vectors. And cosine measures the orientation change, basically. How far are these vectors from each other in hyperspace? Like, what is this like angle? And then there's inner product, which, as I was saying earlier, is part of cosine. And so it's actually much less calculations to do. And so I think inner product is a more effective method, a more efficient method. And it's basically cosine when all of your vectors are normalized. And what inner product actually is if you have one vector and you project another vector on top of it, you get that distance. That's what inner product is actually measuring. And then there's L2 or Euclidean, which is basically, the distance between 2 points in space. So if I have these 2 vectors that point like this, it would be the distance between the tips of my fingers. And this would be the square root of all of the sum of, x squared, x minus y squared. And in reality, we actually implement this without the square root because, once again, the rank order will be all the same and it's less calculations.
Awesome. If you could just touch on why should people care about some of these, like just distance measures in general? Is it just the like index construction, or like how does it play also into the kind of the retrieval portion?
Yeah. Well, actually, I was going to touch on that in range search. So we have introduced this new feature into Milvus called range search. And that's where these kind of come in. So despite the fact that they all have the same rank order, the actual value of the numbers that they return are going to be different. And that's when you're going to have to think about, so when you do range search, which is getting back all of the vectors within a certain distance, that's when you have to start thinking about which one of these am I going to implement, which one of these have I implemented. But also, like, these kind of have a slightly different meaning to each of them, I guess. So L2 or Euclidean is, it's measuring this distance in space. It's more like how far apart are 2 things, like semantically. So apple and orange are probably further apart than apple and frying pan, but apple and frying pan may have similar cosine distances because they're both related to cooking, as opposed to, apple and, like Taylor Swift or something like that. So it's kind of just, it depends on, once again, what you're measuring and what you need to do with your retrieval.
Awesome.
Yes. So then one of the other things that you can mess with is the index selection. And the indexing is the process of creating the way that you're going to access your data. And we offer many, many indexing strategies. I think we offer 11. I touched on 4 earlier. Here, we're going to touch on 3 primary or popular or main indexes, however you want to think about it. These 3 are well known and commonly used. So HNSW stands for Hierarchical Navigable Small Worlds. So you know why they just shortened it down to 4 letters, because it's really hard to pronounce and it's a really long word. And essentially what it does is it creates these like layers of graphs. So it begins with all of your vectors and it creates this graph where it knows the distances and which ones are closest. And then a certain percentage of those vectors are also stored in the layer up, and so on and so on. And so you're creating this kind of like layered graph. And then at query time, you're starting from the topmost layer and you're finding the closest vector in the topmost layer. And then you're diving down to the second highest layer, and so on until you get to the last layer where you can find the closest vectors. So this is really good recall. It's like 99.9%. The drawback for this is basically that it takes up some memory. It takes up a lot more memory. Not necessarily a lot more memory, but it takes up more memory than the actual vectors themselves. And it has to be done in memory, so you have to have quite a big RAM to do this. The next one is IVF, or inverted file index, and this is essentially this is a k-means clustering. Algorithm. You basically say, hey, I want some number of means, and it creates that number of clusters, and it has pretty good recall. But you have to kind of play around with IVF a little bit more to get better recall, because depending on how much data you have, you're going to want to tune that. The number of clusters that you have. But the nice thing about IVF is it takes much less memory, because you don't need to hold all of the vectors as well as their relationships in memory. And then at query time, essentially you tell it, I'm going to query this number of clusters, and it will find the number of cluster centroids that are the closest to your vector and query within those clusters. And the last one that I want to touch on is quantization. And quantization is essentially bucketing. So let's say you have the, this isn't exactly how it works, but let's say you have the range of real numbers from 0 to 10. The way you would quantize this is you would turn this into the range of integers from 0 to 10, and then you would assign values like, all the values from 0 to 0.5 are now 0. All the values from 0.5 to 1.5 are now 1, or things like that. So essentially it's creating these buckets. And quantization does not have as good recall as either of the above indexes, but it does use a lot less memory, because suddenly, you don't have to work with float 32, float 64. You can work with N16, Int8, whatever kind of vectors that you need. So the actual values of the vectors take less bits to store, and B, you're storing less vectors basically. And then one cool thing about Milvus is that we allow you to combine these indexes. So you can't combine HNSW with IVF, but you can combine HNSW with quantization. So you want your high recall, but you want to make sure that you're also having a reasonable memory usage. That's when you would do something like that.
That's pretty awesome. Yeah, that's pretty awesome. I'll say I learned something new there. I didn't know you could combine both indices with Milvus. So very cool.
Oh, yeah. And then there's embeddings. And so, as I was saying earlier, embeddings is one of the most important parts of working with vectors. And so there are, I pick out these three things as very important with embeddings. And that is picking the model. This is clearly the most important thing. And then picking what to embed, right? Where earlier we were talking about the chunking and the chunking strategies. That's kind of what to embed. And then the metadata, which is kind of, what metadata we want to include as we store our embeddings. So here I've included a few embeddings models that you can use. So Hugging Face and PyTorch are probably the most well-known open source. Well, they probably were the most well-known open source sources of machine learning models, and they're really good for embeddings models. And the reason they're really good for embeddings models is because they're free, and you can even use hosted endpoints, and they're easy to use. And then I've got a bunch of large language models here. So Llama 2 is the Meta's large language model. It came out. It's very good. It's pretty big as well. And large language models can also be used as embeddings models. But I also want to be really clear here that embeddings models and large language models are not necessarily the same thing. You can use one embeddings model and another model for your large language model. Okay, so yeah, that's Llama. I assume everybody knows about OpenAI and Anthropic, as we were just talking about, like Anthropic's 200K context window, and everyone kind of knows ChatGPT. That's kind of what made the Gen AI kind of blow up. And then up here in the corner, we've got AI Blocks, and this is a very, very small company, but they do something cool, and they have these specific open source LLMs that are trained on a specific type of data. I think it's finance and legal data. And so I wanted to include them as a way of saying, like, there's also these sets of models that you can use that are fine-tuned for specific data sets and are also open source.
Awesome. I know we're running a bit out of time, so I think we can kind of zoom through a few of these slides at the end. But I can give you this one.
Okay. I can also zoom through this one. So there's 3 layers of embedding strategies. So one is you just chunk the embeddings blindly, just say, hey, here's a chunk, we're going to embed it. Number 2 is sub or super chunks. Llama Index calls this big to small or small to big. Essentially, what you do is you take a paragraph and you embed a sentence, or you take a sentence and you embed the paragraph. And essentially, this allows you more flexibility when you're querying. And then level 3 is you want to incorporate your chunking and non-chunking metadata. Where is your data located? Who made it? Who wrote it? Who's it for? Et cetera, et cetera. So your embedding strategy is going to depend on your accuracy needs, your cost needs, and your use case needs. And you can find the optimal embedding strategy using evaluations. And I'm sure Josh will say a little bit more about that.
Huzzah. No, I think we could just keep pushing through the Q&A. So I'll let you cover range search, and then I'll leave everybody with a notebook link where you can try a bunch of this stuff out.
Okay, cool. So range search is basically, this is what I was talking about earlier. You want to search within a certain distance. So this gives you vectors, vectors that are within a certain semantic similarity to your input vector. And as I was saying earlier, also it's different for each distance metric. Each distance metric is going to give you a different result for the distances. And the main use case for this is how do you want to find close enough to your semantic search to return a vector.
Awesome. Well, this session was a ton of fun. It was great hanging out with you, Eugen. I always
Oh,
learn
yeah.
something when we get to chat. So it's definitely a lot of fun on my end, and hopefully it was a lot of fun on everybody in the audience's end as well. I just want to leave everybody. So if you scan this QR code, you'll see a nice example where you can use both Milvus and TrueLens in combination to do some of these selections we talked about. So choosing your embedding model, choosing your distance metric. All of these things you'll be able to kind of walk through both how to make these decisions and then how to evaluate them with TrueLens. And with that, I can stop sharing and pass it back to Alicia.
Thank you so much for this session. We've got a lot of positive feedback from people, and that it was really, really easy to understand for our community as well, like how to work with vector database in Zelis and the capabilities part as well. That was amazing. Thank you so much for the session, and we hope to meet you all on Discord as well for the Q&A part. And I would love to close the hackathon with a few more, sorry, not the hackathon, but the session today for the kickoff stream with a few more reminders. And also remind about the access to Google Cloud Vertex part for those who might miss this part or still you're starting the evaluation now. So I just want to recap on this. So if you have any questions for this hackathon, do you want to chat with mentors or talk to mentors from partner side, please use the channel that is listed here on Discord. So you will be able to chat with people that are relevant for this hackathon and talk to mentors. Or of course, use I Need Help channel in case you're lost. And then use Tech Mentor. It will just ease our interaction with you so we can know and find better person for your specific request that can help you specifically with your question. Moving on, I want just to recap on the Google Cloud Vertex AI access. So there is two ways you can get the access. First one is when you have your own account and you're working with credits. And the second, when you're using our own infrastructure for the hackathon participants. For those that create a new account on Google Vertex, Google Cloud Vertex AI, they are getting 300 free credits for newbies, and these credits you can use for this hackathon. In addition, everybody that will form a team, so you will join or create your own team for this hackathon, you will automatically receive 30 credits, 30 Google Cloud Vertex AI credits. It will be based on the data we have on LabLab. So if you want to get your credits as soon as possible, make sure to create or join a team in the next minutes and less than an hour, because we'll be sending the first phase shortly. And after that, if you have any issues with creating your own account, or if you already ran out of credits, we have our own infrastructure provided for this hackathon participants. To access this infrastructure, make sure that you have your own team and you're a team leader in this team. And in your team page, you will see a specific component about request access to Vertex AI API. And you can use this button and instantly you will get the access details on your email that is connected to your LabLab account. So make sure you will recall on the steps and make sure that you have team created for this hackathon, because it's a crucial step for you to get credits and be covered when it comes to the LLM provider for this hackathon. Thank you so much for the stream, and I'd love to see you all on Discord and to chat with you there. If you have any questions, feel free to ask mentors there and we'll be happy to help you. And see you on Discord.